So I'm super happy you guys find this angle side stuff pretty easy. And I don't want you guys to ever really think angle side stuff is hard. It's really not. But it is time consuming. It really can be. I do recommend, even as we do the next section, try, practice one of those once in a while just to keep it fresh so it doesn't get, I don't want you to get to the point where it's easy now, we move on, and you kind of forget that stuff was easy and forget all those, because there's a lot of little intricate little things in that to keep track of. Moving forward though, I want you to put yourself in mathematician shoes of original person trying to solve these triangles, right? You've developed the law of sines. The law of sines works beautifully, right? Law of sines, awesome. I love this. What is the problem with the law of sines, though?
It doesn't work
It doesn't work all the time. It doesn't work if you have a side angle side case, right? If you're in this situation, I don't have a pair. I can't use the law of sines. It also doesn't work if it's side, 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 right? So for these two cases, I have an issue. Okay? I need to have some other law. I need to have some other way to solve these triangles. I know this triangle exists. I know this is possible. I just don't know how to find the angles because the law of sines doesn't work, right? So we got to come up with some other tool that we can use for these cases. So here's where this comes from. Let's take, we'll go B here, we'll throw A up here, and it really doesn't matter. So the math of this is going to be the same no matter where we put A, B, and C. But we want to come up with a way of solving this triangle. You say, well, let's draw an altitude here. We'll call that H, okay? Now, do I care about H? No, I really don't care about H, but let's use it to maybe we can come up with a rule going forward. Also, do I know, I know this whole side down here is A, right? Do I know this little part right here? No. Do I know this little part here? No. Is it going to be half of A? No. It's a portion of A. Let's call this X. If this is X, just this little part right here, what's this little part going to be then? Can we name this little portion?
Yeah, let's make it Y.
Well, we could use Y, but we could be more specific.
Y.
I don't know what it is, but isn't it whatever A is minus X?
Sure.
So we don't need to come up with another letter. We can use it. We already know it's whatever the whole thing is minus this portion, right? Let's throw a Pythagorean theorem out there. Let's see what happens with a Pythagorean theorem. What squared plus what squared equals what squared? So what would C squared equal?
A squared plus B squared.
No. C squared is going to equal H squared plus A minus X squared, right? Now, keep in mind the goal here. Do I care what X is? No. Do I care what H is? No. I want this all turned back into terms of A's, B's, and C's, right? So my goal here now is I want to eliminate everything that's an X and everything that's an H. Let's FOIL this out and see what happens. So I get C squared is equal to H squared plus, this would be A squared minus 2AX's plus X squared, right?
Yeah.
Now, looking at what I have here and looking back at my drawing, what is H squared plus X squared? Over here, what would H squared plus X squared actually equal? Wouldn't it equal B squared? I can substitute. I can get rid of these two X's and H's right here. right now and turn those into a b squared. Now, what do I have left? Well, I still have that c squared. I still have this a squared, right? And I still have that minus 2ax. I'm almost there. I've almost accomplished my goal just in that one substitution. I just need to get rid of that thing, right? Now, that's not squared, so I can't do any more Pythagorean theorem substitutions. So I got to come up with something else that would just equal x. Let's think SOHCAHTOA. What kind of sine, cosine, tangent equation could I write that would have this x in it? Well, first off, what angle am I going to want to use? Why C? Why not A? A kind of got split, didn't it? So I don't really want to use A. Obviously B, I don't want to use B. I want to use C here. So what trig function? I could do tangent, but tangent's going to include that h, and I don't really want to bring another h into play. What would cosine of C equal? X over b. So when I butterfly this, x is going to equal b times the cosine of c, right? I can substitute this into my equation. So what I get is c squared would equal a squared plus b squared minus 2a, but instead of x, I'm going to write times b times cosine of c. This nasty thing, that is one version of what we call the law of cosines. Yeah, I understand it's kind of ugly. It really is. There are 3 of them. I'll write them all together. You may want to write these down. The law of cosines. There are 3 of them. One of them says sine c squared will equal a squared plus b squared minus 2ab cosine of c. That's one of the 3 versions. The other 2 versions, the math is exactly the same. The only difference is when you cut this, instead of drawing this altitude, you draw that altitude, or you draw that altitude. The math becomes exactly the same. The only difference would be the numbers the letters get moved around. So instead of a squared, you have one that says b squared equals. And what do you think b squared would equal? A squared plus c squared minus 2 AC's times the cosine of b. And then there's a third one. That would be a squared would equal b squared plus c squared minus 2bc's times the cosine of little a. These are your 3 laws of cosines. Now, for any problem that you do, the first thing you have to figure out, number 1, side, 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 angle, side, I have to use the law of cosines. Number 2, which law of cosines should I use? Should I use the one that starts c squared? Should I use this one that starts b squared or a squared? The decision of which one to use is always determined by the angle. Either the angle you know or the angle you want to find. Okay? So, for example, let's go back to this first side angle side problem. What angle do I know?
45.
Which is angle A. Because I know angle A, that tells me I have to use the law of cosines that has angle A in it, which is the one that starts with a squared equals b squared plus c squared minus 2bc cosine of A. They gave us angle A, so I have to use the law of cosines with angle A in it. Does that make sense? So let's plug in our given information. Do we know side A? No. Do we know side B?
Yes.
That's 18, right? So 18 squared plus, what's side C? 10 squared minus 2 times 18 times 10 times the cosine of 45. This problem, the hardest part of this, honestly, is just how do you calculate it? And the easiest way, type the whole stinking thing into your calculator. Just as is, just type it in. So what I would type in for this would be 18 squared plus, plus 10 squared. I'm not even going to bother calculating 18 squared. I don't care what it is, because I'm just going to let the calculator do it. Minus 2 times 18 times 10 times the cosine of 45. I'm going to type the whole thing in one line. The calculator is smart enough to do order of operations for me, so it knows it has to do all of this multiplication before it does the addition subtraction, right? And then I get that answer. Is that my answer? No, that's a squared equals the 169. So what do I actually have to do here? Square root. And if you wanted to, you could have hit the square root button first and then put this all under one big square root. That is also another way of doing this in one line.
So
That's the answer. So side A is 13.0.
And are we always,
Now, what's that?
Are we always only going to have to find one side or all the sides?
No, now you got to find everything.
Oh.
Now here's where it gets a little fishy. The law of cosines is a wonderful law. It's kind of ugly, and it's way uglier and worse to use than the law of sines. The law of sines is super easy. But I still got to finish this triangle. I still have to find the other two angles. Now, there's two rules of thought on this. This is one of my favorite things to teach. I have a choice right now. The question is, can I switch now and finish this with the law of sines?
Yeah.
Why do you say yes?
Because
Because I have a pair now. And I agree. Depending on whose class you're sitting in. If you were sitting in Mr. Schran's class right now when he was still teaching, and he was standing in front of you teaching this, he used to teach the law, the rule. Once you start a problem with the law of cosines, you have to finish it with the law of cosines. You're not allowed to switch. That is one method to avoid the problem. I have a better solution. This is where I kind of make up my own math sometimes. Here's the problem. I have a choice. I can go sine of 45 is to that 13.0, right? And I can do sine of B is to 18, or I could do sine of C is to 10, right? I have an absolute choice. And the question is, does it matter? Yes, it absolutely does matter. There's a major problem here. With both of these, what am I going to have to do at the end of these? Inverse. How many answers are there to each of these? There's two. If I did this one, and I said, all right, I'm switching to the law of sines, and I said 18 times the sine of 45, I divide that by, and I'm not just going to type in 13. I'm going to go up and grab the whole thing, right? Don't use a rounded number. Just go up and grab the whole thing. And then I'm going to inverse sine this. If I told you that the answer to this question, that angle B was 77 degrees, this angle up here was 77 degrees, would you say that seems like a reasonable number? Yeah. But because I did an inverse, shouldn't I also do 180 minus? Another answer to this is 102. If I said this answer was 102, would you say that that seems like a reasonable answer to this?
Yes.
Yes. How could this be an obtuse angle? Well, isn't it opposite the biggest side? That makes sense. But it doesn't have to be. We can have an acute angle. The question is, which of those two answers is the correct answer? I don't know. I honestly don't know the answer to that. There's no way to tell which answer is correct. The problem is, this could be, the biggest angle here could be an acute angle, but it also could be obtuse. Now here's where the great mathematician, and he really was, people don't realize that he was a great mathematician, but the great mathematician Ricky Bobby. You guys remember who Ricky Bobby is? What's Ricky Bobby's favorite saying?
First, you're last.
If you ain't first, you're
I
last,
have a picture
right?
of that in my living room. My dad put it up.
If you ain't first, you're last. Here's the problem. The biggest angle is the problem here. I don't know if this biggest angle is acute or obtuse. But the smaller angle, angle C, remember I had a choice here, didn't I? I could have done this, or I could have done this one. This same proportion has two solutions. If I told you that this angle C here was an obtuse angle, why not, Ronnie?
Because it's the smallest.
It's the small. It's opposite the smallest side. There's no way this one could be the obtuse angle, right? I know this angle has to be acute. I know that this proportion, when I solve that one, and I say 10 times the sine of 45, divide that by my 13, so I got to go up and grab my 13, right? And I inverse sine this. I know I have two solutions here, but I also know I don't care, because the way the geometry of this works, there is no way that angle C here could be an obtuse angle, right? I know that this has to be the 33, right? And then how do I find the last angle then?
180.
I do 180 minus. So now I can just go 180 minus the 45, and then minus now the 33, and it's 102. So it happened to be the obtuse angle.
It's kind of like
So the question is this. It's all about order. The biggest angle is the problem. Ricky Bobby said it best. When should you find the biggest angle?
Last.
Not just last. If you ain't first, you're last. You either do it first and get it out of the way, or, like in this problem, did I have a choice of doing it first? No, because they gave us an angle. I can't find the biggest angle first because they gave me one of them. So instead of doing it first, I have to save it for last. Just don't do this one second. Okay? Now, a question like this one, side, side, side. The biggest angle is the one that causes the problem. So, we either get it out of the way and do it first, or you save it for last. That is totally up to you. In this question, which angle should I do first? B. Let's just get it out of the way. That's the only one that has the potential to be obtuse, isn't it? Let's use the law of cosines to find that one. So which law of cosine should I use? The one that starts a squared, b squared, or c squared? B squared, because I want to find angle B. So we use b squared equals a squared plus c squared minus 2ac cosine of b. Do I know side B?
Yes.
Yes, 19 squared. Do I know side A? Yes,
14
it's
squared.
14 squared. Plus, side C would be 12 squared. Minus 2 times 14 times 12 times the cosine of B. This problem, the worst part of this is the basic algebra of it. Here's what I see a lot of people do wrong. It comes in, how do you solve this? And they go, all right, well, I'm going to figure out what 19 squared is. How am I going to solve for b? What am I going to do with this 14 squared? How are you going to move the 14 squared to the other side? You're going to subtract it, aren't you? So, great, minus 14 squared. What are you going to do with the 12 squared? You're going to minus it, aren't you? What do I have to do with all this stuff? You're not going to add it. How is all of this connected to the b? It's multiplied by b. So what do I have to do here? I have to divide by that. So what I actually have to calculate is this. Okay, so what I want to type in, 19 squared minus 14 squared minus 12 squared. Get that answer. Then I want to figure out what negative 2 times 14 times 12 is. Get that answer. Then what? Then divide. You're going to divide by that. Don't make the mistake of adding this to the other side, because this is not connected with subtraction. It's connected with multiplication. Does that make sense? It's a common mistake. What's the next step? Inverse cosine. This is the law of cosines. Don't press the sine button. Now, I know, wait a minute, I'm doing an inverse. Doesn't all inverses have two solutions? So I'm going to have the same problem, aren't I? When is cosine negative? What two quadrants is cosine negative? Second and third. What kind of answers are in the third quadrant? Like 200 degrees? Do I care in this case about the third quadrant? No. The second answer is irrelevant. If that was a positive, I'd be doing first and fourth quadrant. An angle can't be 300 and some degrees. That doesn't make any sense for a triangle. The law of cosines, you don't have to ever worry about the second answer because of the way the quadrants work. So that's where the law of cosines is nice. So angle B, sure enough, happens to be an obtuse angle, which is fine. This is the only one that had that possibility. Can I now switch to the law of sines and not have to worry at all about that weird scenario? Yes, because I've already gotten the biggest angle out of the way. The only way you run into a problem with switching from the law of cosines to the law of sines, because we all want to, the law of sines is way better, isn't it? The only way you run into a problem is if you find the biggest angle second. First or last? Yes?
Why? Is it because of that it's in the second word that you don't do 180 minus? Why didn't you do that?
I only know one angle right now. Oh, why didn't I do it?
Yeah.
Because what quadrants is, this is a cosine. What quadrant is cosine negative? Second and third. How do you get to the third quadrant? You do 180 plus the reference angle, don't you? So I don't even have to worry about finding that second angle because it's irrelevant. I mean, I can't have a triangle with an angle of like 200 and some degrees. That just doesn't make sense. So I don't have to worry about the second answer ever with the law of cosines. Now, could I have used the law of cosines to find angle A or find angle C first? Yeah, it'll absolutely work. But then I would have to wait until the end to find the biggest angle. The biggest angle is the one that, when you switch to the law of sines, you have that potential problem of, I don't know which angle it is. And there's really no good way to tell. You have to kind of wait to the end. Does that make sense? So that's where the Ricky Bobby rule is a really nice rule. The biggest angle is the one that could cause the problems. You do it first, if you can, or if you can't do it first, you save it for last. Make sense? Easy? All right, everybody take a look at page 166.